Hello friends, welcome to the lecture number 1 of partial derivative. Partial derivative. Right. So before we discuss partial derivative, so first we're going to discuss about function of two variable, function of two variables, function of two variables and limit and continuity. Okay, so in this lecture we are going to discuss about these two topics before we jump up to the partial derivative. Okay, so from the next lecture we're gonna learn how to differentiate partially, that means how to perform partial differentiation. Okay, so before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. Okay, so now let's start. And one more thing, important thing, that is, this is my Insta ID. So Oja Lakhyajit LAKHYAJIT 123. This is my Insta ID. So if you want to follow me on Insta, then you can follow me. Okay, so now let's start with our first topic, that is function of two variables. Okay, so now what do you mean by a function of two variables? Function of two variables means a function of two variables. So let me first write the definition. Z is said to be a function of two variables right? Suppose x and y. Suppose x and y, right? If z has one definite value, for every pair of values of x and y, right? So we can represent using symbols this z is equal to function of x comma y, right? So that means z is said to be a function of x comma y, that means x and y, if suppose if you replaced x by x1, y by y1, you have used two values for x and y, and it's corresponding the value of this function f of x1 and y1 is suppose c1, and if you change these values x2 and y2, then if you are getting the value of z is equal to suppose function of here x and y. So now x is x2 and y is y2. Now you are getting different values, suppose c2. Okay, then this z is said to be a function of x and y. So let me give you an example for better understanding. So first let me clean this slide. Okay, so for example, let me write for example. So let us consider a cylinder. Okay, let us consider a cylinder here. This is the cylinder, and let me draw the cylinder properly. Okay, so now you see, if its radius is r, and the height is h, then volume of the cylinder is given by v is equal to pi r square into h. Here the pi is constant, that is 3.14, or you can say 22/7 approximately. So this part is constant. Okay, so the value of v depends on r and h. If radius is increased or h is increased, then value of v will be increased. That means if you change r and h, then the value of v will be changed So that means for different r and h you're gonna get different value of v. So we can say v is a function of r and h, right? So here r and h are the variables. These two are the variables and pi is constant. So this is function of two variables, that is those are r and h. So hope you have got it. So now let us discuss about limit. Okay, so a function which is a function of f, x and y, okay, is said to be tend to a limit L as x tends to a and y tends to b if and only if corresponding to this corresponding to a positive number epsilon, positive real number epsilon, that is belongs to open interval a comma b. Okay, so a and b are real numbers, and there exists another positive number delta such that mod of f of x and y minus L is less than the epsilon. Okay, and for this condition x minus a whole square plus y minus b whole square, that should be less than delta square and greater than 0, right? So hope you have understood this. So I think you are not getting it, okay, from the definition. Let me give you an example. Okay, so let me go to another slide and let me give you an example. So I'm going to explain this with the help of an example, then it will be very easy to understand. Suppose we have a function, let me take that function f of x y, which is given by x into y. The function is x into y. Okay, so then if we find the limit first, before giving you the example, let me show you just how to calculate the limit of this very simple function. Suppose we need to find the limit of this function f of x and y when x tends to 1 and y tends to 2. So that is equal to limit x tends to 1, y tends to 2. Here the function is x into y. The function is x into y. So first limit x tends to 1. First let us find the limit of x into y for y tends to 2. So if that is the case, then what we can get here we're going to put y is equal to 2. Then what we're going to get, limit x tends to 1. Here we're going to have twice x. When you put y is equal to 2 using this limit, if you evaluate this limit, then you're going to get twice x, right? So then again, now if you put x is equal to 1, then it's going to be equal to 2. So now let me explain the definition of the limit that we have written here. Okay, so now you see, this is the L for this particular function. For this particular function, this is the limit L. Okay, and here x tends to 1, y tends to 2. That means x, here you see we used to write here x tends to a, y tends to b. So here a and b are nothing but, so just one minute, let me copy this last step, this one. So let me copy this, and here is the last step that I have written in the definition. Just wait, and let me make a box here so to explain this. So now you see, in this case this epsilon belongs to open interval a to b. So a and b are real numbers. This is the real number line. Suppose this a must be somewhere on this line, real number line, and this must let me take this one as b, and epsilon is this belongs to this open interval, so it must be lying between a and b. Okay, it must be a number between a and b. So now here you see, in order to explain this definition of limit, so let me give you an example here. If you compare this here, if you take this function as an example, here the limit we have got 2, and this was for x tends to 0, x tends to a and x tends to b. This definition was written for x tends to a and x tends to b. So in this case, in our example here, we have taken that is x tends to 1 and x tends to y tends to 2. So that's why in this case a is equal to 1 and b is equal to 2, right? In this case a is equal to 1 and b is equal to 2. So now let me make columns here. This is suppose just wait, 2 and 3 and okay, 4, 5. Okay, just wait, let me make it longer. So here this is x, this is y suppose, and here we have the mod of f of x comma y minus L. Okay, so in this case, for this example, in this case it's gonna be x into y, the function is x into y, minus L is 2. So this is gonna be this mod of f of x minus L, right? F of x and y minus L. So in this case, so now x minus a whole square. So in this case x minus a is nothing but x minus 1, because a is 1 here in this example. Here for this example a is nothing but 1, so this is x minus 1. Similarly this is y minus b, so y minus b whole square, that's going to be y minus 2 whole square, because here b is 2 as y tends to be 2, right? And let me write this column for make this column for x minus a whole square plus y minus b whole square. That means sum of these two values. Okay, so now you see, as when we say x tends to 1, so that means this value of x approaches to 1 from the maybe from left side, maybe from right side. So approaches to 1 means tends to 1 means it may be 0.9, 0.99, 0.999. So this is tending towards 1, right? Similarly it may be tending from the other side as well, right? So it may be 1.01, just wait, 1.01, 1.001, like that. It tends towards 1. So similarly for 2, y is equal to 2. So if y tends to 2, then we can consider that 1.9, 1.99, 1.999, these values are close to 2, right? So hope you have got my point. So now you see, just wait. Now let me write x is suppose 0.9 and y is suppose 1.9. This is close to 2, 1.9. And for that case, what will be x into y? X into y minus 2. X into y, if you multiply these two, what are you gonna get? 81, so 8 carry, right? 171, and point before 2 is 1.71 minus 2, and that's going to be equal to 0.29 minus 0.29, as we are taking mod here, as we have mod here, so that's why it's going to be positive, right? So first value we have got for these two values of x and y. Let me write here. Now for these two values of x and y, we have got here 0.29. That's what we have got. right? So hope you have understood this. So this is what we have done here. So we have done mod of 0.9 into 1.9, that is x into y. This is x into y, right? X into y minus L in this case 2, that is equal to this 0.29. That's what we have got. Similarly, now let us take x. Value of x is suppose 0.99 and that of y is suppose 1.99, and then if you calculate the value, if you use the calculator, as I have already calculated, so you're gonna have 0.0299. okay, you can check by yourself. Then if you take x is equal to 0.999 and y is equal to 1.999, then this value gonna be equal to 0.00299, sorry, 999, not 99. That's what we're gonna have, right? And then x minus a. So here in this case our a is 1. So if you subtract, if you find x minus 1, that is 0.9 minus 1, that's going to be what? So here you can see that's going to be 0.1, and as we have square here, so squaring this, that's going to be equal to 0.01, right? 0.01. and here also we're going to get 0.01. okay, you can check yourself. So if you subtract this one, if you subtract 2, as I have written y tends to 2, so b is 2 here, so b is 2, so y minus b, that's going to be minus 1.9 minus 2, that's going to be again 0.1 on squaring 0.1, on squaring 0.1 we have got 0.01, right? So hope you have understood this. So then here what we're going to have, we're going to have 0.02. Similarly for the other values, just wait, let me make it underline here. For this pair of values of x and y, we have got this value, and here what we're going to have, here we're going to have 0.01 on squaring, it's going to be 0.001. okay, if you subtract 1 from 0.99, then you're supposed to get minus 0.01, right? Here we have square, so on squaring this you're gonna get this result. So hope you have understood this. So now let me write the results. So hope you have understood how to calculate these kind of things. So here also we're gonna get 0.001, right? So then it's gonna be 0.002. Similarly, in the next row, what we're gonna get here, 0.00001. Here we're gonna have 0.00001. Here we're gonna have 0.00002. That's what we have got. Now you see. Okay. Now let me take a new slide. Here you see, in this case, just wait. Let me make a little bit of adjustment here. Just wait. Here only I'm going to explain. Okay. So now you see. Let me take the first case. Let me take this first case. Okay. Just let me take a highlighter here. Okay. Just wait. Okay. Let me take the first case. This one. This one. Sorry. So let me reduce the opacity. Okay. So this column first. Sorry, this row. So here you see, what are the values? Let me write again. 0.9, 1.9, 1.09 into 1.9 minus 2, here its mod is equal to 0.29. Here that means we can write here, let me write the value here. We can write what we have got, 0.29. that is what we had got here. This is 0.01, this is 0.01, this is 0.02. Here you can see clearly that this value, here you can see that should be less than epsilon, which belongs to this open interval. That means epsilon is a value between a and b. So now here you can see this clearly. This value for these two, we have got 0.29. This is equal to, this is nothing but mod of f of xy minus L. So here in this case L is 2, right? L is 2. This is less than, you can say what is the a and b here. What is a and b? A is in this case we had taken x comma 1, x tends to 1, y tends to 2. So a comma b is nothing but our 1 comma 2. So now you see this is 1, suppose this is 2, number line 1 and 2. Between 1 and 2 we have numbers like 1.1, 1.2, those numbers. And here we have got this is equal to 0.29, and 0.29 is equal to is less than this value is less than epsilon, which belongs to 1 comma 2. So when we say one open interval 1 and 2, open interval 1 and 2, that means this means the values, set of the values between 1 and 2, that is, it may be 1.1, it may be 1.01 as well, so 1.2, 1.3, and as we are getting here 0.29 is less than 1.1, 1.2, right? So this condition is satisfied, right? So this condition is satisfied, right? So let me just wait, let me take a new slide, then you will understand better. So here you see, so what was the definition? According to the definition, this, if L is the limit of this function x comma y, then mod of f of x comma y minus L, that should be less than a positive number epsilon. This epsilon belongs to a comma b, as x tends to a and y tends to b, and x minus a whole square plus y minus b whole square, that should be greater than 0 and less than another square of another positive number. Okay, so what are the values we have got in this example? Here you see this table. If you see the first row of this table, okay, let me copy this table and let me go to the new slide. Okay, let me copy this table. Okay, so here you see, here is the table. If you check the first row, here for the first row we have got this value is equal to 0.29. okay, and here a comma b is nothing but, for this function here you can see, as I have written here, x tends to y, x tends to 1, y tends to 2. So this a is nothing but 1, b is nothing but 2, and so this is less than any value between 1 and 2. Any value between 1 and 2, it is, this 0.29 is less than any positive value epsilon, which belongs to 1 comma 2, right? Because between 1 and 2 we have numbers like 1.01, it may be 1.02 or 1.11, 1.21, such kind of values. So 0.29 is less than 1, so it is obviously less than a number between 1 and 2, right? this first condition is satisfied. Now let's come to this part. Okay, so here you see, for the first row you can see sum of this one and this one, it's become 0.02. This has become 0.02, which is greater than 0. That's this condition is also satisfied, greater than 0 and less than some positive number. So what kind of positive number? It is not specified here. So it is obviously a less than. So here in the definition it is just said that if this function said to be tend toward the limit L for x tends to a and y tends to b, if there exists for real number epsilon which belongs to a comma b, if there exists another real number, that is delta, another positive real number, that is delta, which satisfies these conditions, right? These conditions. So here you see, this is obviously less than some positive number. It may be less than the square of 0.2 square. It is 0.2 square is 0.04. So it is less than 0.04, right? So this positive number is not mentioned what kind of positive number it is, just it is a positive number. First, it is some positive number. Okay, so here we have seen that both conditions are satisfied for the first example. Similarly, you can check for the second row, third row as well. So you're going to get the same result. So hope you have understood this. Now let's discuss about the continuity. So before we discuss continuity, let us solve some questions. So let us evaluate these limits before we discuss about continuity. Okay, so let's evaluate these limits first. So just quit. Sorry. So here you see. So first one, a. So what we have here, limit x tends to 0 and y tends to 2. So we need to evaluate the limit of twice xy plus 1 by x square plus y square. So first we need to check for any value, either x or y, x is equal to 0 or y is equal to 0, does the denominator become 0 or not? If not, then you can solve it easily. Okay, so if it becomes 0, then there must be we must do some simplification. So we're going to discuss later. First let me show you how to solve this one. So first we're going to write limit x tends to 0. Then again, as we have two variables here, again we're going to write the limit y tends to 2. Then the function, what is the given function? This is the given function. Here you can see this is the function, right? So for y is equal to 2, if denominator is not equal to 0, for y is equal to 2, then you can put the value of y here directly. So then it becomes limit x tends to 0. So on putting y here, y is equal to 2 and 2 here, then what we're going to get? We're going to get 4x plus 1 divided by x square plus 4. That's what we have got on putting y is equal to 2, right? As y tends to 2. Okay, so hope you have understood this. Now let's put x is equal to 0. On putting 0, denominator doesn't become 0. So that's why we have no problem with this. So you can put x is equal to 0 directly. So if you put 0 here, this becomes 0. 0 plus 1, that's going to be 1. 1 by 0 square plus 4 means 4. So this is the limit of this function as x tends to 0 and y tends to 2. So now let us solve this. Now you see B, solution. So here let me copy this. What we have, first let me write limit x tends to 1, then again limit let me write the function of this y tends to 1. So first let us put y is equal to 1, then it's gonna be, that means first let us evaluate this part. If you put y is equal to 1, then it becomes x cube minus 1 cube is simply 1, then x square minus 1 square. That's what we're gonna have, right? So now if you put x is equal to 1 here, it's gonna be equal to 0. So that's why we're gonna use these identities. That means we're gonna factorize this. So in order to factorize this, we need two identities here in this case, for this particular case, that is x cube plus, so we have minus here, x cube minus y cube, that is equal to x minus y into x square plus xy plus y square, and another identity is x square minus y square, that is x plus y into x minus y. We're going to use these two identities here. So then limit x tends to 1, if you apply this identity x cube minus y cube here, then it's gonna be x minus 1 into x square minus, sorry, not minus, x into 1 is x simply, then 1 square is 1, and divided by, here apply a plus b into a minus b, or x plus y into x minus y, that is x plus 1 into x minus 1. So here you can see now this term cancels, these two terms cancel each other, okay, for which x is equal, if you put x is equal to 0, it becomes 0. So this factor is now cancelled. So that's why if you put x is equal to 1 here, then it doesn't become 0. So now you can put x is equal to 1, so that is x square plus x, that is 1 plus 1, then 1 plus 1, and that's going to be equal to 3 by 2. So this is the answer. So hope you have understood this. Now let's discuss about continuity. Now you see a function is said to be continuous, function f of x and y is said to be continuous at a point a comma b if this limit exists and it is equal to f of x and y at x is equal to a and b. Okay, so that means if you put here a and here b, whatever the value of this you're gonna have, that must be equal to this limit, right? So hope you have understood. If not, let me give you an example, so it gonna give you clear view. Okay, so now you see, suppose we have a function question, so that function of x comma y is equal to 2x square plus y for x comma y is not equal to 1 comma 2. Okay, when x and y are not equal to 1 and 2 respectively, then this function is given by this expression, and otherwise it is when x is equal to 1 and y is equal to 2, then this function gives 0 for x comma y is equal to 1 comma 2. This function becomes suppose 0. It is such kind of a function for x is equal to x comma y is equal to 1 comma 2, it becomes 0, and otherwise it becomes 2x square plus y. Okay, such kind of function. So we need to show this function is discontinuous sorry, let me write here, is discontinuous at 1 comma 2. So how to solve this solution? So first let me write the given function as it is. Okay, so this is the given function here. So first let me find the value of f of ab. Here ab is nothing but 1 comma 2. This is our a comma b, right? So f of a comma b, that means f of 1 comma 2 is equal to, when x comma y is equal to 1 comma 2, it is equal to 0, so we can write directly 0. Now let us find a limit. Limit x tends to 1 and y tends to 2. here the point is a comma b is 1 comma 2, so x tends to a, that is x tends to 1, and y tends to b means y tends to 2 here. And here you say x and y tending towards 1 and 2 respectively, but not equal to 1 and 2. Okay, so that means here we're going to use this expression for this function, right? Twice x square plus y, because for x and y not equal to 1 comma 2, this function f of x and y is this, right? So as here x is here x tends to 1 means x is not equal to 1, it approaches towards 1. Okay, so hope you have understood this. So now you see, now evaluate the limit, as we have already done, we have already discussed how to evaluate limit. So limit x tends to 1, then limit of this twice x square plus y when y tends to 2. So if you put 2 here, so then what you're gonna get, limit x tends to 1, and if you put 2 here, x is y is equal to 2 here, then what you're gonna have, then you're gonna have 2x square plus 2, that's what you're gonna put, you're gonna have. Then put x is equal to 1, then what you're gonna have, so 1 square into 2 is 2, 2 plus 2 is 4, that's what we have got. Now here you see, this is not equal to f of 1 comma 2. Limit exists here, limit we are getting 4, but it is not equal to f of 1 comma 2, because this is equal to 0. Okay, so according to the definition, this limit must exist and equal to f of x and y. Value of it must be, this limit must be equal to value of f of x and y at x is equal to a and at x is equal to b. So here a and b are nothing but 1 comma 2. The value of the function at x is equal to 1 and y is equal to 2 is 0, but the limit is not equal to 0, so that's why this function is discontinuous according to the definition of continuity, right? So therefore, just wait, therefore f of x comma y is discontinuous at 1 comma 2. So hope you have understood this, right? So hope you have understood this. So thank you for watching. See you in the next video. Stay connected and do share with your friends and inspire me to create new contents for you. Thank you. Bye bye.